Hi everyone, and welcome to another edition of Air Conditioning Intelligence. Today we're talking about BLDC motors. BLDC motors is something that we're really starting to see used quite a bit in the ductless and mini split market. They can be a little bit confusing just for the fact that it's something that we're not used to seeing in the industry, but we're going to explain these today and tell you how to diagnose these and how you can work on these in the field. Now if you take a look in front of us here, if we can remove the cap of these, we're going to notice that we see two different styles of motor. As you can see, this one here has its own circuit board inside the motor itself, along with the one that you see below it. And now right next to it, you're going to see a motor that's very similar in design, but no circuit board inside the motor. You're going to notice that this is 3 wires. Okay, going into this motor all the way down to the plug. I'm going to shut this off for right now. Here's our plug for that motor. As you can see, we've got 3 wires going into that plug, basically designating that it's a 3-phase motor. Now, this is, I hate to use the term dumb motor, but doesn't have a lot of smarts in this motor. You're not going to see a lot of circuit boards or anything happening in this motor. We basically have 3 wires and we have 3 windings. Now, how do we know that this motor is intact? Is that we can take our resistance meter, measuring in ohms. In this case, I've got an auto meter. And we can come just winding to winding. Now, you want to make sure that you're poking the epoxy. There's an epoxy coating on these. We're right about 98.6 on that winding. Let's take a look at the next one. And we're going to be right about in that same range, 98.6, or about 10%. Okay, so we're good enough on that one. Now we're going to come over to this and check this last winding. 98.6. And as you can see, 3-phase motor, we're going to have equal windings on that motor. And you're going to be able to be very confident that these windings are intact and able to run. Now, looking over here at the other one, I'm going to go ahead and remove this motor out of the way. Again, guys, take a quick look at that 3-phase motor. We're basically checking the resistance on this motor. And again, the PWM, the pulse width modulation for this motor, is taking place inside the main circuit board of the unit itself, whether it be an indoor unit or an outdoor unit. 3-phase motors like this in the field with no electronics tells us that the PWM, the pulse width modulation, is taking place within the main circuit board of the unit itself. Now, when we take a look at the motor that's left, this is what we call a 5-wire BLDC motor. And normally, you're going to notice 5 wires going into it. Generally, these wires stay the same color across the board, across the industry. As I've seen, they've pretty much standard colors, and each one maintains its standard purpose. As you can see, we've got a red, we've got a black, we've got a white, a yellow, and a blue. Okay? Now, this being a BLDC motor, most people refer to these as a brushless, digitally commutated motor, a brushless DC motor. Really, whichever way you want to describe it, it really doesn't make any difference. A BLDC motor basically is a DC motor driven off of DC voltage. Now, when we take a look at these first two, you have a black and red. Your black will be the reference to all the measurements that you take on this motor. You're going to take the measurements of this motor in a live state of electricity. So in other words, you're not going to come up to this motor and do a resistance check or anything like that. You're going to want to check the motor live while it's in place, plugged into the circuit board of the air handler or condenser, whatever unit you're working on. And when we come and take a look at this, of course, you're going to be taking these measurements at the Molex plug. I'm going to show you these measurements at the board just for the sake of better clarity. I think you can see it a little bit better than the plug itself. But we're going to take our black lead of our meter, and that's going to be your reference to all measurements taken on this. Okay, so we're going to take our black lead, and we're going to start right here. And again, you're taking these measurements at the Molex plug. So as we go to the first measurement, you're going to be looking at the red and the black. You're going to be looking for about 300 volts DC. If you're working on a unit that's a 220 volt primary voltage. If you're working on a unit that's 110 volt primary, then you may be looking for somewhere about 180 volts DC, maybe 185 volts DC. This voltage should be constant and present the whole time the motor is powered, whether you're in a standby state or not. There should be 300 volts present at this reading all the time. If there's not 300 volts present at this board, then you can tell with pretty much certainty that your circuit board inside feeding the power to this motor is defective. Okay, our next measurement we're going to take is going to be over here to this white wire right here. And when we take the measurement from black to the white wire, this is our voltage collector. Okay, and so this is basically our voltage control collector. There should be 15 volts DC present at that reading the entire time the unit is powered. Whether the motor is in a standby state or the motor is attempting to run, there should be 15 volts power present at the black and the white wire all the time the motor is running. Now as we move up the chain, you're going to see a yellow wire next to it. The yellow wire is our speed selector wire. Okay, now there's a lot of different terms. It's called a VSP wire. I use the term speed selector because the more power that I apply to that yellow wire from a range of 0 to 6, the faster and the slower the motor will turn. So if I am applying 6 volts from the black wire to the yellow wire, I would expect to see that motor running at high speed. If I had applied 3 volts, again this is in DC, to the yellow wire, I would expect to see that motor run at about half speed. So it's a proportional there from 0 to 6 volts that dictates the speed of the motor from low to its max speed. Okay, so again, this is our speed selector depending on how many volts we send to the yellow wire, and again reference from the black. This is a signal of somewhere between 0 to 6, 6 being the highest speed, and anywhere below that basically modulating the speed down at that point. Now if we take a look at this blue wire that you see here, this blue wire is actually a field generated pulse. Every time we make one revolution with this shaft, we send a pulse down this wire back to the processor, basically saying, hey, I just did one revolution. And that's how our processor is able to understand the speed of the motor and maintain the speed of the motor. So again, basically a field generated pulse that comes back from the motor goes to the processor, letting it know the speed of the motor at that time. Okay, so again, this is a DC voltage motor. We're looking at 300 volts present at the red wire, or 180 if you're doing a 110 volt unit. 15 volts present DC on the black to white. Every time the unit is powered, every time the unit's in standby or running, there should be 15 volts present. Again, the voltage between the black and the yellow wire is going to be in a range between 0 to 6, and depending on 6 being the highest speed, 0 being completely off, it will proportionately set its speed dictated on the voltage measured on that wire. Again, the blue is a field generated wire. Every time we do one revolution, we basically send an electrical pulse down that wire, letting know the processor exactly how fast the motor's going. Folks, we appreciate you guys taking your time out to take a look at our video today. We're going to be posting a whole lot more of these. Again, if you have any questions, please reach out at the description below, and have a great day.